Right, this video is to do with checking to see which version of Python you're using. Now, where this comes in useful is if, for example, you wrote a program on your PC and you were using Python 3.14 point something, and you wrote your program and then you thought, oh, I'll run that on my Raspberry Pi, it ought to work, but your Raspberry Pi is still using Python 3.10, for example, and the program is using features that have only come in Python 3.14. So you can put in your program, is the version of Python new enough to be able to cope with this program? And this is really all there is to it. Not very interesting. So I've got some pictures. This is the newest addition to my family. He's called Gregory. Another picture of Gregory. And this is our house. And I wanted to show that our house is very topsy-turvy. You can see by the fact that the door isn't straight at all. I don't know how that came about, but I don't think it's likely to fall down. I mean, it is about 250, 270 years old, so I'm not that worried. And there's Frankie, and I think he was looking up at a hot air balloon going over. So I will just put that back to Gregory and get on with the program video. Now I'll start off by showing how some people might look at this and think, oh yes, this is how to do it. Right, so first of all, I will, everything on the left hand window I'm just using to cut and paste, doing all the work in the right hand window. So there we go, importing sys and print the sys version. And there we go, 3.10.11. Wonderful, that is a string. And you think, I'll be able to do something with that. So you might say, I'll do, if it starts with 3.10.11, correct version. Yeah, it does start with that, but if then we move on to version 3.11.0, it will not work. So there has to be a better way. So then I thought, try this. I've split it up, so I've actually got a variable called version which is nothing but 3.10.11. And then you can go like, if the version is greater than equal to 3.10.11, correct version or later. Yeah, so that would work. So if it was 3.10.11, yeah, 3.11 so everything would work. But if it was 3.9, which isn't a later version, it would still work. So I will show you what I mean. Here, I'm pretending that the current version is 3.9. So it says if the version is greater than 3.10.11. Well, it is, because 9 is greater than 1. Is the correct version. No, it isn't. No. So that means you can just forget really about using sys version, because it doesn't help you whatsoever. So you want to find something else to use. So now we can try using sys.version.info. So here we go. I'll just copy that in. Right, sys.version.info. It says the major version number is 3, then minor 10, micro 11. Right, and that's all in a nice tuple. So that looks a bit hopeful, doesn't it? And you can even access the, you can access them separately like that. Right, so you can find out the major is 3, the minor is 10, the micro is 11. And you might think that from that you could do something like that. It looks good. If the major version is greater than or equal to 3, yep, and the minor version is greater than or equal to 10, and the micro version is greater than or equal to 11, then it must be okay. But no, because imagine if the major version was 4, that would be true, but then the minor version would start off at 0. So that's total nonsense. You can't do it like that. By this time, you're getting a bit desperate. So you write something like this. Now I haven't actually tested this, but the logic is as it ought to be. So you can go, if the major version is less than 3, it's definitely not good. If it's greater than 3, it's definitely okay. Else, and when you come down here, else, that means that the major version is equal to 3. And then you start checking the minor version. And as up there, if the minor version is less than 10, nope. If the minor version is greater than 10, yup, definitely. Else, you then have to go on and check the micro version. And down here, you know that the major version is 3, the minor version is 10, and you just have to check whether the micro version is less than 11. If it is, not good, otherwise it's fine. Now, you'd have to be, that would work, but you'd have to be pretty desperate to do that. So we'll go on to something else. So this is where tuple comparison can come to the rescue. So if we have that, we've got two tuples and they look the same. Not the same object, but the same values in there. So you can go, is one tuple equal to another tuple? And what it does is it goes through and it says element by element, and it says is 1 equal 1, is 2 equal 2, and as soon as it finds something where it isn't true, or it reaches the end, it will come to its decision. So there it will come to the end and it says, yeah, it's all true, so it's true. And if you put in, I don't know, if you change, whoops, if you change that to a 2, it will check and it will go, is 2 equal 1? No. And then it won't bother to check the rest. It thinks, no, 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 it can't possibly be true. So that will come out as false, which is all fine and dandy. And it doesn't, if they aren't the same length, they'll never be equal, because if you put another 3 on the end, it will check yup, 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 and then it says I can't check that against that, it must be false. So that will be, I'll clear that, that will be false. So that's all terribly easy for equals, and you can really see what's happening. Now if you put in something like less than equals, this is nice and easy as well. So if that's less than equal to tuple 2, so it go less than equal, yup, less than equal, yup, less than equal, yup. So that will come out as true. And if you put in a 2 there, it will come out as false. But if they aren't the same length, if you put an extra element there, it will go yup, 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 and then go, no, that 4 isn't less than equal to none, so it has to be false. I'll get rid of that. That will come out as false. But if you put in, whoops, like that, you're now comparing 1 with 1, 2 with 2, 3 with 3, and you're saying, is minus a million less than none? And none isn't naught, none is none, and it still will come out as false. I'll put that, yep, false. So it doesn't matter what the value of that is, whatever it is will be greater than none. And you can put in like that, and it compares, and then it's saying, is none less than that? So that has to be true. So that is quite easy for less than equal to, and the same logic applies if it's just greater than equal to. Where it gets a bit hairy to think about is if it's less than, just less than, because it's going through and it says, is 1 less than 1? No, no. I have to think about that. I have to wait till the end. Is 2 less than 2? Well, it isn't impossible yet, and is 3 less than 3? And it, oh no, I've reached the end, therefore it will be false. And it's trying to work out, that will come out as true, because it's trying to work out the logic of what it's doing. And what it is actually doing, I believe, is if you change that line to not greater than equal to, that is exactly the same thing. And what it does is, forget the not first of all, it goes through and it says tuple 1 greater than equal to, right, is 1 greater than equal to 1? Yup. Is 2 greater than equal to 2? Yup. Is 3 greater than equal to 3? Yup. So that comes out as true, but you're knotting it, so it comes out as false. That is more what the program is doing. So that is enough on that. I just wanted to do something. And of course, with these less than and equal tos, you can say you can use min and sort and max for things like that. So back to what we were actually doing. So getting back to the whole point of the exercise, where I'm just printing the version info and the type of that, and there it goes. There's everything as it was before, major, minor, micro, and then it says that the type of that, the sys.version.info, is a class. But I've realized that you can actually treat that as a tuple. So there. If sys.version.info is greater than equal to 3, 10, 11, right, so what it does is it compares that to that, yep, that's greater than equal, that to that, that's greater than equal, and that and that, that's greater than equal. And then I've run out there, but I'm still going here. Is that greater than none? Yes, hurrah! You're running Python 3.10 or higher, so there we go. And just in case you're wondering whether it wouldn't work if they weren't equal, I could go 9 there. Are we running a version later than 3.911? Well, I'll change, oh, I want to change that. Yep. Oh, apart from I didn't change the comment, but that's about how it works. Right, we'll just have another quick look at tuple comparison, like that. Two tuples, two lists. You could do exactly the same with a list as a tuple. So I'm just going, if list 1 is less than list 2, no it isn't, because they're the same. So if I change that to that, yes it is. So it works in exactly the same way. But what you cannot do is you cannot say, is a list less than a tuple? It doesn't like that at all, at all, at all, at all. I mean, what you can do, of course, is you can go, if it's equals to a tuple, and as they aren't the same object type at all, that will work. It will come out as no. Even if the values were the same, it will come out as no. But if you do want to compare them, as in less than, equal to, greater than, blah blah blah, you can just go something like that. So is list 1 less than the list of tuple 1? And that's yes, because 11 is less than 12. If we change it back to 12, that will come out as no. Right, so that was just a quick look at that. Then you can do things like sort and min and max. So if we look at that list, list 1, blah blah blah, you can just go print min list 1. That ought to work. And there we go. 0, 1, 0. Yep, that is the min. And you can go max. And yep, that's the max. That works okay. And you can sort them as well if you wish. So, whoops. Oh, I might as well copy it from there. Can't copy anything. Right. List 1 dot sort with no parameters. Like that. And it sorts it, and it doesn't care about the length. It's looking at the first item first, which is 0, and then that one is 0, 1, and that's 0, 2, so that's right. And then so that comes in at yeah, that comes out in the right order. You can go reverse equals true, for example, like that. Yep, biggest, smallest, smallest. Or you could go key equals len, and there we have, from minimum, you know, for ascending order. So that's 3 long, 3 long, 3 long, 4 long, but it doesn't, it keeps them in the same order. It doesn't, so that one was the first, so it's 0, 2, 2, 3, 1, 2, 1, 1, 2. It doesn't care about the values of those at all. And you could even do that. Yeah, so it's the longest one first. Now there's another time that I think tuple comparison might come in useful, and that's with angles. I don't like radians, I prefer degrees. So you can have an angle 45 degrees, 19 minutes, 10 seconds, and compare it to 44 degrees, 53 and 12, and it works like anything.